and Jupyter Notebook because I have to import this file into my Jupyter Notebook, right? I use the same thing, pd.read, because it's the Excel file, right? Um, I have to use Excel here, and I open brackets, and inside quotation marks, I will just copy address location of this file. I'm coming the file again, and from the properties, I just copy this location section. Do you see that? As I copy it, I also memorize the name of the file, and also I look at the extension of the file, because in addition to that, this location, I have to also write the name of the file, also extension of the file, in order to import this data into Pandas. Yes, I'm coming again. I'm just copying the same thing. You can change this symbol, but I don't need that. You can just write here R, and after that I will just add the name of the files. It is Loans, right? And it is a XLSX file, right? If yes, when I run this command, as you can see, we got the same data. Pandas read the same data from an Excel file, and we copied and paste the same data as a Pandas data frame. This is a special name. It's mainly the same thing when you look at the Excel file. It is also Pandas data frame also consists of a table which includes, for example, rows and also columns, right? It's the same. Yes. After importing this data, the next step I have to do is, also you have to do, is to look at your data. This is very short data, as you can see. And the first step, the next step I have to do is to look at whether there are any missing data or not. Um, you have to go through the lines. For example, as you can see here, credit history column here, there are some missing data, right? For example, the second row says that unknown, unknown. It means this is a missing data I have to deal with. In the previous tutorials, I couldn't, we did not go through how to deal with the missing data, and this tutorial also we will deal with how to we can deal with the missing data. The one thing we have to do is to first of all to select our column what we have to deal with. df, but we have to assign a variable name for this data set, because without assigning any a variable name, I cannot use it, right? Because I will use a lot of functions, so I have to get the columns, so I have to use a variable name for this importing data. Yes, now I have called and run the same code, and now my df file is ready, right? So I can call. It is like calling a keyword in Python's dictionaries, right? I just write the name of the column I want to deal with. This is credit history. You can just copy from here because it is very easy without it prevents from misspelling, right? When I run this code, as you can see, I separately called this column. What I have to do is to use map function. Um, what this map function do is I create a dictionary inside this function. The first one is I can write the name of the original value, and I can change this value what I like, what I want to change. Okay. For example, when it comes to bad, I will not change this one because it's not missing. So I just assigning bad is equal bad. But when it comes to unknown, I will change this one. Um, so we have to decide which value we have to change this one. as you can see, there are two values, bad or good. And in generally, it is changed with the most common one. As you can see, good as a data, good as is more than the bad one. So I just use the median of this one. I will assign this one as good. So this code will change all the unknowns values with good. And if it was a numerical value, I can use the mean of the entire column or the median of the entire column. There are many options, but when we go through these tutorials, we will encounter different kinds of problem. But because this is a very short data, and I know that good is the most common value, so I'm just changing unknown with the good. And also good, I have to write all of them because map is will go through entire code. If I not, for example, write one of them, for example, I will not write good. When I run this code, as you can see, it changed all the. This is the original one. You can see it. I will copy and run this one. This is the original column, right? As you can see, it changed bad has bad, no problem. It changed all unknowns into good, right? But when it comes to good, it has right here none. This means missing value. So therefore, I have also right here good. Good. If the code come encounter with good, it will also assign good the same value. So because I don't want to change this one, right? So when I run this, as you can see, I changed all the missing unknown values into good, right? But this one is not enough. This is just visualization of the code. I have to assign these changes in the original column, right? I'm just copying this. I say that df credit column is equal into these changes, right? So when I call df credit history column again, as you can see, it has changed. It will never return to previous data because I now I state that please assign these new values into entire column. So this is the new version of the credit history column, right? Okay. So let's see again the entire our data set. As you can see, I don't see any missing values, right? There is only one, and we dealt with this problem. Yes. So to this point, have you got any question or any adding comments? It's okay.
Yeah, can you show again how you got the table into Excel? I can't figure it out.
Okay. How to import the Excel file, do you mean?
No. You copied the table from the document.
Oh, okay, yes.
Yes. The teacher posted.
Yes, Eric, it's okay. This is the original document that I download from my email, as you can see from your emails, right, or Canvas. You can see this is a table, right? So I just come here and copy this one, control copy. I just do this. And after that, I copy it with control copy. And I come to my desktop and come to new. I say that because this is Excel, this is a table. So I create this file as a Excel file, right? I give this one a name. For example, let's say this loans 2, right? And I open this empty Excel file, and I just control V and pasted the entire data into Excel, right?
Well, it doesn't work for me, but I guess I have to just write the table.
Can't you copy this from the Word document?
No, I tried it sometimes. But
maybe I can send the data
yeah,
from you from chat. We can try like this.
yeah.
I will try to send you by chat. I could not say. Maybe
You
I
send
can.
it in the Discord server.
Yes, Discord service is okay. Yes, nice idea. I'm opening Discord. Yes. From streams, right? I will add a file from my desktop, and this is the loans, right? Now I added Eric. Maybe you can download from here. Can you see the file?
Yeah.
Okay.
Thanks.
No problem. Bari higeli. So until Eric gets download and come to the same page, we can go through what we have done to this process. First of all, we have imported necessary libraries. Without this, we don't have any legs and arms. These are our arms and legs to do something, to do an action with machine learning. When you work with machine learning in your future or artificial intelligence, you have to, these are the pillars of these pathway, right? So you will encounter again and again these four libraries, especially these two, NumPy and Pandas. And after that, I just imported my data. It was an Excel file, so I just used read Excel. If it's, for example, an CSV file, underscore dot CSV, I will do the same thing. I will just copy entire address location of the file inside the quotation mark. I will paste the entire address location and I will run this code, right? So the next step after importing data to check what about the data. So is there any missing values? There are several functions we can deal with, but this is a short data, so I will not use these functions. So we will use and we will learn in the future coming tutorials. And I see that in this credit history column, I see that there are some missing values. I just use a normal Python function. This is my column name that I want to deal with. I just use map function. Map function, what map function do is take the original data into new data what I want to add. So it transform bad as bad because I don't want to change this one. If, for example, I want to just show you, if I say instead of bad, if I say, for example, 1 or 100, right? When I run this code, as you can see, each transformed all the bats into 100. So if it's a numerical data value you want to transform, you don't need to use quotation marks, but if it's a string, you have to use. So because bad is a string and I don't want to change, I just write the same bad here because it will, I say that transform this one into the same value. Transform unknown into good. Transform good into good because I don't want to change good. But what I want to change just unknowns, right? So after I just run this code again, because I changed the same value before as 100. So I have to say this one 100 because we changed our data, right? When I call this one, when I showing this one, yes. I have to say maybe 100 because we saved 100, right? As far as I remember. No, not important. We can recall again. So the errors is always we will encounter, right? Yes, this one bad. Yes. No, Eric, are you ready?
Can you just go to the top so I can see
Yes.
what you imported?
Imported data here. We just read the Excel file. What you have to do is just copy address location and copy and paste it inside the quotation marks.
Yeah.
You have to use R before the quotation mark. And in addition to address location, this is address location in my computer. It can be different in your computers. And you have to write the name of the file. This is the name of the file, loans. And this is the extension, because the extension of Excel file is XLSX. So I just writing here .xlsx. And after that, I just run the code.
Okay.
Okay.
Yeah.
So I am dealing with the missing values. This is the only column that has the missing values. So I just transformed the credit history into good, because good is the most common value entire column. So I just write, say that please, when you encounter unknown, please transform this one into good. Okay. This is my choice. But it's a reasonable choice because it is the most common value. I assume that the most of these unknown should be either bad or common, but because good is the most common, I just assign this one good. Because in the real life, we will encounter these very difficult data, so we have to deal these missing values, and we have several methods we will learn in the future. And yes, this is my PF history, right? Credit history. Yes, this is my original column. We have changed, as you can see, credit history has been transformed into good, right? So after this one, so as you can see, income, I also come to income. I think I have to also transform these values into reasonable values, right? This says that I think fewer than 15,000, right? 15,000 kroner. So the algorithm will not understand this one. Also, we have to deal with this one. I will choose the same code math function. First of all, I have to choose the column name, right? This is my data frame. This is the name of the column. So I choose the column, right? This is the column name. I will choose the same. I will implement the same function, that math. I am creating a dictionary inside this open brackets, inside this function. And I am creating a new dictionary, assigning the previous values into the new values, what I decide. Okay. As you can see, I just copied this one because it is hard to write. I'm just copying and Control V and pasting here. This is the original data, right? Because this is not a specific value, right? It can be 1,000, 2,000, we don't know. So I think it is very reasonable to just assign this one 1. It's not important because I will assign, if it is 15,000 and 25,000, I will assign to 2. And if it is higher than 25,000 kroner, I will assign to this 3. And the algorithm will understand, because this is although it seems numerical data, but it is just a categorical data. It categorizes entire income into 2-3 categories, right? If it is fewer than 15,000, and I will just assign to this one 1, and the algorithm will understand. If it is between 15,000 and 35,000, I couldn't. I will try again. I'm just copy and paste it here, right? I will say that, as you remember, if we are assigning a numerical value, we don't need to use a quotation mark. We just use quotation marks when we are dealing with strings. So when it is, so I'm coming the next one. So as you can see, this is a normal dictionary in Python, right? But I have to use quotation mark because it's a, because it is a string. I'm sorry. Yes. If it is bigger than 25,000 kroner, I assign this 3, right? When I run this code, as you can see, it changed entire column into reasonable numerical values. 3 different categories. If it is, and it is very reasonable, if it is fewer than 15,000, and it will assign as 1, category 1. If it is between 15 and 25,000, category 2, and if it is bigger than 35,000, category 3, right? This is reasonable. So the next step is I have to assign. I didn't change the column name. Just I used a function to how to change my column. So I am copying the name of my column, or I can write, but in order to save time, I'm just copying and writing here equal. I say that this is my previous column, but I say that we have to please equal the new values, this column, into this new transformation, data transformation, right? So when I call the same column name, as you can see, it has changed. Now, by writing the column name, we have changed the entire column with new values, right? You have to do that. Without doing this, it will continue with the previous data. So when I'm calling entire my data set again, data frame, as you can see, now income has been transformed into 3 categories that the algorithm will understand very good, right? And when you choose mapping these strings, you have to use, I think, reasonable data. So I think this one is the most reasonable way to assign new values that the algorithm will understand. So we have to transform all the data, all the features into numerical data. You have to remember always. But except from the target, this is the risk of someone. This is the features. If someone has these features, is there a risk of giving loans, right? This is the entire data set is what the entire data set means. If, for example, these features is credit history bad, debt high, collateral no, and income 1, it means that high risk of loans. Yes. Now I am ready with the other one. So I'm calling this one. As you can see, there are several strings. For example, credit history is bad, good, bad, good. There are 2 separate categories, but they are strings. When I come to debt column, also it is string, and there are 2 categories, high or low. Okay, and category collateral and yes or no. Income we have dealt with, and risk I will not change because this is my target according to data the professor provided. You can use the same function, right? You can use map function. You can change if this map function will encounter, for example, high. You can transform this one 0 or 1, whatever you like. Also, you can use the same function for this data. But I want to learn you another function that you can use instead of this is a very useful function when you have encountered in order to transform from strings to numerical data. You can use this is pandas pd dot get dummies function. We can use help function in order to see what this function is about, right? And I will explain to you. when I run this code. This function convert categorical variable into dummy variables. What dummy means? It means 0, 1, 2, 3, that easiest numbers that the algorithm can understand very well. If, for example, it will assign 0, for example, this low, and assign 1 when it comes to high, right? And if it has another column, it has another value, for example, medium, it will assign to 2. So this function will deal with all the strings and transform them into numerical values. And you have to use very often this function. And I'm just open brackets. As you can see, the first parameter is the data. What the data this function has to deal with. I am writing the parameter. My data is df, right? This is the entire data df. And after that, I am writing comma. And the other important thing is columns. What columns do you want to transform, right? I will not transform entire data, right? So I have to write, I have to fill also this parameter, right? Columns are equal. I am opening close brackets, and I will write here the name of the column I want to transform from strings into numerical data. And as you can see, this is my data. The numerical, you can see here again, the numerical, this is my data frame, right? For example, we have to deal with his credit history, right? So I'm just writing here, copying credit history, and I'm coming here, I'm pasting here, because I want to transform this credit history. You can't transform all of the strings by one code, but I will show it separately. And because first of all, I want to show if you want to show just one column, well, sometimes you just need to transform just one column. But this is not case in our data. There are several columns, but first of all, I will transform this one. And the other important one is drop first. This means you can read here. It will not, for example, if there are, when we call the function, you will understand better. I will explain this one. The first equal true. It's the Boolean value, true or false. When I run this, as you can see, this is my original data, right? Because I have not changed it. I changed credit history. It was before bad or good, right? Now when it is transformation, after transformation, credit history has been transformed 0 or 1s, right? As you can see. If it is bad, it has transformed to 0. If it is good, it has transformed to 1, right? For example, if I have not used the first one, drop first function, I'm just taking this one, as you can see. If I run this, as you can see, it will create two separate columns, and it will assign, okay, this one is credit one is if it is bad, 1, or if it's good, 0. But it will increase the burden of the machine learning algorithm. So I am just dropping this one because I don't need to assign two separate columns, because if it was 1, so it means the other one it is not 0. So there is no need to show that it is also it is not equal to 0, right? So if it is 0, it means that it is not 1. So there is no need to show that again if it is not 1, right? So therefore, I am just dropping first and run the entire code again. As you can see, it just assigned the first one because my column is credit history bad or good. So it has dropped the bad one, and just created only one column, new column. You cannot see credit history here. You can only see credit history transformed version of the credit history. And if it is good, this is just asking it is good or not. If it is good, 1. If it is not, 0. And also this means that if it is not good, if it is this means if it is not good, it means 0. It means that it is bad, right? We come here, it is bad. If it is good, it assigns 1, right? So I don't need to create another column whether this credit history bad or not, because I understand from here, from only one single column, and the algorithm also will understand from a single column. This is the reason why I am using drop first parameters. Also, I am trying to show you how to read the documentation of the coding, right? Yes, I will use the same function because I just want to show you in a separate column, but you can use this the entire code for more than one column. I will use the same code, PD, the same function, get dummies, right? This is my function. Get dummies. I will do the same thing. Yes, data parameter is df, right? I am also using, I have to select the columns because if I not select, it will use entire data, it will transform entire data. This is not what I want because I have already dealt with this income. Also, there is target volume. I don't need to transform this one. So I have to select columns. Columns are equal. Now, after opening closed bracket, I need to choose the columns I want to deal with, right? Inside quotation marks. I have already dealt with income. I have already dealt with, but I have to assign this one df again, because if I not assign, it will not transform that data frame. So I have to assign again. I say that the new version of my data frame is here, or in order to df latest, I can say df latest in order to see the separation, the changes better, right? This is my latest version of data frame. It means that now I can, instead of df, I will use df latest because I want to deal with the latest version of my data frame. And I will use this one when I for the machine learning algorithm, not the df, because df is the original data. So I just use the df. I can change df instead of, I can use data frame name df instead of df latest, but I will lose entire the original data. But when I implement the machine learning algorithm, if I use a separate variable name, this gives me the opportunity to compare the original data and the latest version, right? So therefore, I assign df latest instead of the df. I hope you understand why I do this. Yes, what are the columns I want to deal with? These are the original version, depth, right? I'm just copying this. It is like creating a list of Python, right? Just I'm writing inside this quotation mark the name of the columns I want to deal with. Depth, also collateral. I want to also change this strings into numbers. Income has already, I think that's done. Risk is my target. This already has been dealt with, income and credit history. So yes, and I have to write also drop first parameter is equal to, so I don't want unnecessary columns. When I run this code, as you can see, so first of all I want to open the original one. This is the original one, right? Depth, it's dropped the depth column. which includes only strings, it creates a depth low column. If it is low, it's assigned 1. If it is not low, it means it is high, it assigns 0. So when it comes to collateral, it creates a collateral no column. Okay. If it is collateral no, if it is true, it assigns 1. If it is false, it assigns 0, right? Yes. If it is no, as you can see here, the original one, it assigns 1. Yes, it means that it is true. It is not, it is no. If it is 0, it means that it is negative. It's not no. That means it is yes, right? So when it comes to collateral yes, yes, as you can see, it assigned a lot of numerical values instead of strings. Yes, I think we have to also assign this one to our, because I want to use these latest changes. Df latest is the previous version of my data frame. I'm calling and running this one. As you can see, we have transformed all of the, this is the first version, right? Df, all the strings into numerical values that the algorithm can understand. And there is a number column. This means this is a just index. So it will just make the algorithm complicated. It will evaluate, the algorithm evaluate these are series number, these are features, but these are not features. So I want to drop this one because this means nothing for the algorithm, for predicting the target column risks. This is just index. So I will just drop this one. How we drop this one? Df latest. I'm first of all writing the name of the data frame. I'm using drop method. I'm just writing which column I want to drop. No, this is the name of the column, right? I have to choose axis axis as 1 because when I want to drop the columns, I want to write 1. When I want to drop rows, I have to write here 0, right? When I run this, as you can see, it's not seeing. So there is no number, no column in entire my data. So I have to use in place because I want to use these changes to continue. If you do not use in place parameter as true, it will not change. So I want to this one permanent. So when I call enter my data, df latest, and run this, as you can see, so our data frame is ready for the algorithm, right? All the strings has been transformed into numerical data. This is the only one because it is my target. I don't need to change the target for the algorithm. Is there any questions to this point? Am I fast or not for your pace? Yes. Now we dealt with the missing values. For the next step, we dealt with the strings. And now this is the time to encoding the algorithm, right? We are going step by step. First, we imported necessary libraries, and later we imported to our data, and after that we dealt with the missing values, right? And after that, the next step is to deal with the strings. Now it is ready. So this is the time to call the algorithm, whatever algorithm I want to use. Because this is a categorization problem, the target column is a categories, right? I have to encode categorical categorical algorithms. So from scikit-learn, this is the main library of machine learning algorithm. From three subset of the library, please import decision tree, because I will use this one. Decision tree. As you can see, when you press the press the tab button, you will see two separate algorithms. And I will use classified because this is a classification problem, right? If the risk has been the numerical values, for example, between 1 or for example 1000, any numbers, and I have to use the regression. So I'm using the classifier. I'm running this line, and the next step is to create an instance of this algorithm, right? I'm creating a D3 parameter variable name. I'm calling the algorithm. I'm creating an instance of this algorithm. This is done. You can give whatever name you want to name, right? So I have encoded the algorithm. This means that I can use my algorithm, right? So the next step is to separate my data into features and target, right? I assign my features to X and assign my target to Y, right? This is the common one, but you can choose whatever name you want, but this is the common way. If someone developer reads your document, he will easily understand that yes, you assign your features into X, right? What are my features? I say that if, for example, df latest, this is my entire data frame. If I drop from my entire data frame the risk column, right? And I will write here axis equal 1. It means that it will drop this one, and the rest of the data will be my features, right? As you can see here, it dropped the target, and the rest of the data means my features, right? So I just assign this one to my X, as you can see here. Now I call X again and run the code. And so you can see that all the features of my data frame has been assigned to X. So I will do the same thing almost to create a Y variable in order to assign entire my target column. This is my target, right? I don't need it because I just assign. I mean that df risk column, I just assign this one Y variable, right? And when I run this code, yes, as you can see, the target column has been assigned to Y. Yes, let's come to the questions of your assignment, right? Construct a decision tree for the data shown in the above table that predicts the risk of a new mortgage customer defaulting on his loan using information gained as a measure to which to choose attribute nodes in the tree, right? So I have to construct a decision tree, right? And there should be something more as far as I remember. Yes, not this one. Yes. So we are going in the way, right? So I don't need to separate my column. This is only a very short column. I will just show according to assignment. I will just implement a decision tree algorithm and use this algorithm in order to show information gain and how this algorithm choose for separation nodes for the algorithm, right? Attributes nodes in the tree. So first of all, I have to use my decision tree algorithm, right? The next step is to fit my data. I will not, if it was a big data, if the professor said that you have to separate into training and testing set, he doesn't demand from us this one. He just say that, just fit the data and show me the branches of the decision tree, right? So in order to show the branches or the decision nodes of the algorithm, I just fit the data. First of all, I write the features, and secondly, I write the target one. This means that decision tree classifier algorithm will create a hypothesis between these X features and Y target one. And after that, it will create a decision tree for the feature data, and it will use this hypothesis that this one is created from this fitting point, and it will use the same function or the same hypothesis to predict future data. And when I fit this data, as you can see, this means that the algorithm has fitted the data, has created its own hypothesis or functions to predict Y. To create it has created a connection between features and the target one, right? We can, so as you can see, I will just import another library, scikit-learn. From scikit-learn, we can just say from scikit-learn import tree, because I want to show the separation marks of this algorithm, right? From the previous lecture, you can maybe remember, print, we are using a function from the tree sub library. This is the main library, this is the sub library. I also call the entire algorithm from this sub library, but from this sub library of tree, I will also use a feature, a function. So when I import this one S3, so it means that I can use this entire subset of the library, and I will use, as from the previous lecture, maybe you can remember, we had used an export text function, right? And it will export the entire text formation of the algorithm into a visualization that we can understand how the algorithm will deal with this problem of features and its connection with the Y, the target, right? I'm just writing here the name of my instance of the algorithm. When I run this one, as you can see, this is the way how this algorithm is separating the entire data frame. The features I will call in order to help you to understand better, not X store X. Yes, this is feature 0. This means income. This is the, as you can remember, index of the first column. It begins always 0. This is feature 0. Here we understand that the algorithm has assigned feature 0 as the root node of this classification problem, right? In order to predict the target column. So incomes has been selected as the main one. As you can see, this is a separate lines, and after that it goes to two. One is this one, the other one is this one. This is the first separation point. If the feature 0, it means income. This is my feature 0. If its value is fewer than 2,5, it will go this direction, right? It will create another separations. But if it is bigger than 2,5, it will go to this direction. It will create it will ask another. It will create another separation point, feature one. If it is, for example, if it is bigger than feature one is bigger than 2,5, and it comes. Is the feature one? Feature one means credit history good. Is it fewer than 0,5? If it is yes, then it assigns target as medium. This means that the risk of this feature to give loans is medium, right? If the feature one, it means if this one's income is higher than 2,5, this means that this person has a high income, right? But it also looks at another separation point. If his or her credit history good, as you can see, we have assigned zeros and one. If it is bigger than 0,0,5, and it will assign class as low. It means that you can give credits to this person. There is no risk. The risk of nothing coming back, the money, the loans back, is very low, because this person, it's also meaningful, right? If someone has very high income, if someone has a good credit history, so the algorithm, I think, working very good, predicting very good. It means that if someone you encounter, for example, if you work in a company, if someone, for example, in a bank, if someone has a good income, also good credit history, and it means that the chance of getting back your loans is very high, right? The risk, but in our target is evaluating the risk. This means that the risk of nothing back your money is very low, right? So when it comes to, for example, feature I'm coming to the upper point. If it is fewer than 2,5, right? Then it makes another separation, right? As you can see, feature, it asks again another question. It's making another separation point or root node or another branch node. It says that if feature smaller than 1,5, it will go this direction. It will, and if it is smaller than 1,5, it will say that this person's risk is very high. What this means is, if someone else's income is lower than 2,5, and it's again, is this person's income is fewer than 1,5, this means that this person's income is low. If it is low, the risk is high. Yeah. Yes. If it is bigger than 1,5, this means that, as you can see, I can show DF income, DF latest. Maybe you can understand better, I think. The original data. Yes, we can now use the original data. Yes, we have already changed this one also. Yes, 1 means low, as you can remember. 2 means medium. 3 means high. So I'm coming back. If feature 0 is bigger than 1,5, this means that this feature has at least medium income, right? And it creates another separation branch, separation node by feature 1. Feature 1 is, this is feature 0, and this is feature 1, this is feature 2, this is feature 3 and 4, and this is feature 1. Is this one's credit history is good. If this score is lower than 1,5, and then it will assign this person has a very high risk of not paying back the loans, right? If this feature, as you can see, this is the line first, this is the line, the other branch. If this feature 1, credit history good, is bigger than 0,5, it will create another separation node, right? The algorithm choose for the second or for the third separation point as feature 2, feature 0, feature 1, and feature 2. This means that that low. If someone else's depth point is lower than 0,5, this means that it's also high risk. If it is bigger than this one, it will assign as medium. And this is the evaluation of the algorithm. And you can create, this is the code of this, and you can just use this code, take a picture or screenshot of this code, this separation point, and use your assignment, I think. And you can also evaluate how the algorithm works, right? And you will answer the questions, how constructing a decision tree and predict of risking of mortgage customer defaulting on her or his loans, right? And to which choose the attributes, right? We are now showing the professor how our algorithm choosing the nodes, right? And I think we are answering the questions. I will take a short break, and I will 5 minutes. We will see in 5 minutes, and I will show you how answer the other questions. Okay, just 5 minutes. We will see.
I have a little question.
Yes, Nikolai.
Has it ever been mentioned why the decisions are based off values like 2,5 and 1.5 and not 2 and 1, for example? Why are there decimals? Has that ever been mentioned?
Yes, I will mention after break, because I will show you the entropy of this entire algorithm. This is choosing these features according to the information gain. I will also show you the entire code of how this algorithm choosing entropy, creating entropy, the numbers of the actual real numbers of the entropy of each features, and it is information gain. And it is making these separation points according to information gain. If this means that, what I understand before implementing the code of the entropy of information gain, I understand here that the information gain of the feature 0 or income is very high, therefore higher than the other features. From feature this one, this feature, and therefore it is creating feature 0 or income as the main, as the root node. And after that, it's going, what is the next highest information gain? Which column, which feature gives the next highest information gain? And according to our model, the feature 1 is the next separation point. This means that feature 1 is the next one which gives the next highest information gain. Okay, and therefore this algorithm choose feature 1. And I will show you entire code. Nikolai, I hope is this your answer to your question?
Almost. I think like for example, for the root node.
Yes.
Like at the first one, why is it less than or equals a value in the middle of 2 and 3? Why is it 2.5?
Yes,
is
I
that,
understand. Yeah, not.
Could it not have been, for example, 2 or
Yes.
3?
It could be. It is based off your data. As you can see, our income column has been based off number 1, number 2, number 3. This means that the algorithm choose the best splitting point. If this one has split it from, for example, income as 3, this means that the information gain of this feature will be lower. So the algorithm choose the best splitting point of the column in order to get the highest information gain. This is the reason why this choose. I think the next, after the break, after 5 minutes, we will go through the code of the entropy of the and also information gain. I think it will help you understand why this the algorithm choose not 3 or choosing just 2,5, because it is making some mathematical calculations and finding that according to these mathematical calculations, finding the highest point. It finds first which feature gives me the highest information gains, and after that it will split this feature into a splitting point in order to separate the purity of the data, right? Which, if I split, for example, from feature 0 from the point of 3, this means high. This means that if the algorithm split from that point you mentioned, it will not correctly, it will not provide you a better good splitting. This means that the other data will be more complicated, will be more get in line with each other. And when the algorithm splitting from this point, it will give you more purity. It will give you more separation than other splitting point. And we will continue after the break. I think you will understand better if we say the real entropy and those information gain. I think you will understand Nikolai better when you see the information gain points, why this one choose this one. Okay, just 5 minutes. We will go a little bit faster because we don't have enough time. And so I will show you the entropy of this code and also information gain. In 5 minutes, we will practice. Sometimes I'm mixing. Yes, thank you. Just hello. I hope you hear me.
We can hear you.
Okay, Nikolai. First of all, let's import the visualization of what entropy is, what information is. I just Google it. I find these ones, okay, information gain, and also entropy. I will use these ones for my coding. Let's first of all import these ones into my Jupyter notebook. From properties, I find the address location, white, and this is information gain. It's a JPEG file. So I'm coming again. I think we can understand better with this visualization. Okay, plt.imshow. This will show the image, and inside this function plt, I'm using matplotlib. plt.imread. This will read the image. I'm opening a bracket. Inside quotation mark, I'm just pasting the address location of my picture. Okay, I am writing the name of the file, information gain, as far as I remember correct, and it's a JPEG file, right? I have to write here R, so I don't need to change this symbol. When I run this one, maybe we can take a bigger version of the plt.figure. This will, I can arrange the size of the picture here, fixed size from fixed size parameter. I will show 15. Yes. This is the information gain, right? Did you understand the code? This is the code. I'm reading the file by means of the matplotlib because I imported matplotlib as PLT. You can write this one as a separate code, but I just combined the entire code. This code, plt.imread function, will read the address location of the JPEG file, and the plt imshow function will also show this read JPEG file, this picture. Or okay, I will do the same thing for the other file, and I will explain. I'm just calling this one, but this one is entropy as far as I remember. The name of the file is entropy. And it's because I just copied from the desktop, so I'm not changing the location. Maybe I am misunderstanding. Entropy. No file. Don't think I am. Let's copy from here. Properties. I use the same entropy. Okay, this is a PNG file. This is the reason why this one not reading PNG, not JPEG. Yes, now we are reading. The extension of the file when we read a document or file or picture is very important. If you miswrite this one, and it will not read, no matter the entire code is true or false. Yes, this is the information gaze. This is the calculation of the entropy, right? You can calculate entropy by your hands. It will take a lot of time. This is the formula of the entropy. We will just create the code of this one. This P means probability of this feature, right? This value. It will count the number of this value, and it will divide entire column, and it will find out the probability of this feature. And after that, it will multiply by logarithm in base 2 the probability itself, and it will find the entropy of the first column, and it will go through the second column. How many columns you have? If it has another column, as it is case in our data, it will add another one, feature 1, feature 2, feature 3, and after taking some of these mathematical formula, we will just use minus in order to find out the entropy of this data, right? This, as you can see an example of it. And now what we will do is we will just to formalize this into Python code instead of writing entirely with our hands. It's very difficult, and it is very highly probable that you will make a mistake, and we will make the machine do instead of us, right? First of all, I have to find out counts of each value, okay, in an entire file. I will just name it counts, maybe counts, right? In order to find counts, I will use numpy's bin count function. I will show you what this means. For example, let's choose income, right? Before assigning value, let's run this code. As you can see, df income, right, has been it shows how many each value has, right? For example, 1, first one, second one, third one, and fourth one. This means 1. 2, the first 2, second 2, the third 2, fourth 2, 4. When it comes to 3, we just count each value, how many times each value has its entire column, right? Because we will divide this number into entire length of the column in order to find out the probability of this feature, of this value. You understand this one? This is the way how we will calculate the probability of each data in this entire column. We will do the same thing for the other columns or for the other features, right? Okay. Now I will just divide this one into my length of the column, right? I'm just using Python's length function. This is my I will just name, but I'm using not df latest. Df latest. It doesn't matter for df or df latest for this point for when it comes to income, because income is numerical in both data frame, but when it comes to other feature in df they are strings, but df latest they are numbers. I need numbers because I will make mathematical calculations, right? All the algorithms based on mathematical calculations, not strings. Machines cannot read the what low means, high means. We have to calculate the two numbers. FDF latest income. Yes, when I run this, I have to, I think, separate this one. Yes, that one. What is the problem? Yes, first of all, we can do it separately. I can show you. This is, I'm just taking this one here, pasting here. Maybe you will understand. This is number of counts, right? No problem here. And I'm calling counts variable. Yes, it's working. This is the length of the entire column as far as income. Yes, as you can see, the number of elements in the column is 14, right? As you can see, 14. So it will divide each chance of the feature. There are 3 features. Will divide by the entire length of the column, and in order to find out the probability, right? I'm just creating probability here. You can say probabilities or whatever name you choose. I will just divide number of each element by the length of the function. I'm just copying from here. What happened? I do something wrong. Not counts here. Length. We can write here, it's not problem. Length of the df latest, right? Of the column name income. I'll just run this code. What is the problem? Counts. Maybe I have to separate from here. Yes. You can help me. Sometimes it's very difficult. Okay. Counts. It's creating a number of array, but I don't need the number of array. I just need if I write here length of this column. No, it will not work because it will give the entire, but I need the one by one. Divide by this one. Ah, okay. Okay. It's working, but I don't. I'm not. I'm looking for another one. As you can see, this is the probability of each case, right? This is the feature one, value one. We can see from the entire data, as you can see, just copying in order to help you understand better. Yes, as you can see, these are the number of each feature, feature one, feature two, feature three. This is the length of the entire column. It divided the number of the count of each value by the length of the entire column and find out the probabilities, right? These are the probabilities of each case. The probability of, for example, value one is this, I think 28%, and this is the other one. This is the second one because the number of counts is higher, so the probability of this feature three is highest, right? To this point, do you understand? What I will do next is to create a function. I will just combine this one, right? If you can remember, we have find out the probability. We will multiply this probability of each value by logarithmic in base 2 of each probability, and we will find out each entropy of each value. Okay, according to formula. I'm just following of the mathematical formula. I'm just defining a function. I will name this one calculate entropy, right? I'm just, because I will take the column names, right? I'm just writing it column names instead of doing this one for each column by one. Just I will create a function and I will call the function, do entire job to the function, not me. I'm just copying these ones because I need the counts of each element, but this is only one column. Whatever column I call here, it will count each value, each separate value in this column, and will assign this one counts variable. The next step is I will divide these columns into the length of the column, right? This counts into length of the column. Instead of when I create a function, I don't need to specify the column name. I will just use column parameter, because whatever column I call, it will go through this entire function, right? And I will assign this one to the probability, right? I can say this one, I'm misspelling. Yes. To this point, we have find the number of each value and divided by the length of the column, we find out the probability of each feature, whatever column I call into this function, right? But this is not enough. I will find out entropy, right? First of all, I will assign entropy as equals 0, and after that, I will call a for loop for probability in probability. I will explain you, right? For probability and probability in probability. This means that, as you can see, this is not one single probability, right? This will give us the probability of each value. So I will call each probability because I need to find out each probability, and after that I will multiply by this with its logarithm. Okay, and I will say that because I am using logarithm cannot be 0. In our case, there are 0 data, so I will just say that if probability is bigger than 0, And now I will calculate the entropy, right? Entropy is equal plus artı plus and equal to probability times. I'm just following the formula I will show you. We find out probability and times I will use logarithm of this probability, right? In base 2. I'm just here. I have to import math library. Yes, because I will use this math library. Math library provides us logarithm function, and I will write here the probability, but not base 10, but base 2. Nikolai, do you see that? Probability multiplied by probability in logarithm base 2. I'm just doing the same, this one, okay? I am using plus because I will not just find one probability. If I not do plus, because according to the formula, I need two entire values, right? Value 1, value 2. So in order to add all of them inside entropy. And this will give me the entropy if I didn't any mistake. And I will return not entropy, minus entropy, because according to formula, I need minus entropy, right? If I run this code, now I will call, for example, let's print calculate our function, calculate entropy function. Yes, column name, I will just df latest. I will just call whatever column name I like in order to check whether the functions performs good. As you can see, this is the entropy of column income, right? I will just copy and do the same thing for entire columns. Let's call the column names again here in order to instead of writing each of them, I will just copy, for example, this column name, paste here. When I run this, yes, this is the entropy of column credit history good, right? And I will do the same thing for each column. I have 5 columns, right? So I will do the same thing. Depth log column. Now I am answering another question inside the assignment, I think. Yes, because instead of calculating each of them myself, I'm using computer to do it. I'm just copying I'm just copying to the formula into a Python code. This is what I do. Yes, when I run this, as you can see, these functions is not a very difficult and complicated. I just first find the probability of each value because I will not implement just one column. I'm using a for loop because I am not using just single value, all the values inside the column. I'm using a for loop. I'm using if probability bigger than 0 because if the probability is equal to 0, in our case there are some, it will give me an error because there is no logarithmic of any function of is equal 0. Okay, so it will give me a math value error. Therefore, I have to use this if statement here, and after that I'm just following up probability multiplied by logarithm of this probability in base 2, right? I'm just following this formula, nothing more. And I will add minus because we have to, according to formula, we have to add minus after the calculation of entropy, right? And this is the result. And now I have find out entropy of each column by Python code. The second step is to find out information gain, right? Let's do this also. For information gain, because it's a mathematical calculation, I have to also transform risk from strings into values. It may seem a little bit complicated, but this is the hardest part. And after that, I think we answer all the questions inside the assignment, because we will also calculate the information gain of each column, and we will present why the algorithm choose, for example, I don't know beforehand, this column or this column as a separation point, right? So let's transform this one, our target column, df dot risk, as I remember, yes. Let's use map function. Yes, we can say we have to create a dictionary, right? If it is low, I will assign as 1. If it is medium, I will assign as 2. If it is high, I will assign 3. As you can see, there is a meaning why I am adding these numbers, because from low to the medium to the 3, I'm not choosing randomly any number, because what I choose the numbers is meaningful, that corresponds to the strings, right? Yes, when I run this is the new version of my latest risks column. I will assign, because I want to change this one. When I call the function again, as you can see, I have changed, because when it comes to information gain, it will make a mathematical operation, and it will include also the target. It will make these mathematical operations according to the target, and the target value should be a numerical in order to make mathematical operation. This is why I transformed in this section the risks column, my target column, into a numerical value. Let's create our function. This is the hardest part, and after that we will get ready all the information gain, and I will explain again why I did this. Yes, information gain is this. First, we find out entropy. We have already found out entropy, right, by this function. Okay, we have done this, and we will subtract from this entropy to the conditional entropy of each case, which means that, for example, I divide from feature A1 or feature A2, as you asked me, from 3 or from 2, what will my information gain will be? The algorithm will go and will make a lot of splitting points according to this information gain. So we will calculate first information gain. Let's do it in a function. df, I will create a function of information gain. Inside this function, I will use entire data set, and my split point. This will represent my splitting point inside the column to answer your questions, and also my target. This is my target, which means risk column, right? And this is the original entropy, right? Original entropy. First, because I need my original entropy, because I will subtract conditional entropy from the original entropy. So I have to find out original entropy. I have a function to do this job, right? I just use my previously made function, calc entropy. Yes. I will use, instead of data frame, this is a parameter. Whatever I assign this function, it will use. For example, I will use df, and it will come to df as data, right? And target name. Yes. Yes, after that, this is the calculation according to target name, the original entropy. And after that, I need to find out values, what I did before. I can find the counts, as you can remember here. I'm just now calculating the values from data, but I will use, to choose values, I will use the splitting point. The algorithm will split from this splitting point inside the entire data frame, and it will find out the unique values, right? Unique values means these ones, 3, 2, 1. Not go all the values, but it will find out there are 3 separate values here. It will find out these unique values, right? For example, just visualize it. I will add in order to show you. Let's do it and use unique function and see what this function do. Yes. I misspelled unique. The latest df. I think I misspelled here. Yes, because I have to name that, for example, what the names of the columns. Let's see this. df latest. It's income, for example. Let's find out the unique values in income, right? And I run this. As you can see, it creates an array of unique values in incomes column. But for example, if I, instead of income, if I write here the depth log column, it will return me the unique values. Not all of them. What value pairs I have. For when it comes to depth log column, I have just zeros and ones. When it comes to income, I have 1, 2, or 3 values. If I had, for example, 4, 5, it will also list this one. It will just return me the unique values inside entire column, right? This is the reason. So I'm finding the values, number of the values inside the column, right? And I will separate this column into 2 different sections, because in decision tree I am making an left and right splitting, right? I just write here left split. This is the hardest one, and I will explain it. And right split. For right splits, I will use data and also another data I am choosing inside my data frame, and inside data frame I'm choosing my splitting point. The algorithm will the splitting point, and if this one is equals the values of 0. The values is here, the unique values, the first unique value. I am choosing as my left separation point. I will choose the same thing for my right, but I will change values not 0 but 1 to the right one. Okay, and after that, let's create another variable, subtract and equal 0, because I will subtract the original entropy, not original entropy, from the conditional entropy. So in order to use this one, I am using a subtract variable here as equals 0. and I'm just call a for loop for subset in left split. I will just copy here. Left split and right split. This will create a for loop between left splitting point and right splitting point. Cool. I will now create probability of each conditional data set, right? Let's do it. Subset subset dot shape 0. This will return me the size of this subset, right? Each value divided by entire data size, right? Entire data size. This will give me the conditional probability of this one. And after that, I will subtract. I will use this one. Subtract is equal, but plus equal is probability times or multiply by I'm calling my entropy calc entropy function. Entropy function subset my target to subset to create it, to reach my target, right? Then I will, this is now I am calculating the conditional entropy of each splitting point, and I will return the original entropy minus, right, the original entropy minus subtract the conditional entropy. Yes, if I didn't any mistake, it should work. Let's insert another column here. Let's use this function, whether it works or not. Print, let's print this function. Information gain, for example. This is our data frame, right? We have 3 separate parameter data. Instead of data, I will use data latest, right? And let's choose splitting point as income. As you ask me, if I choose income as a splitting point, what will the information gain will be? Okay, and my target is, as you know, is risk. I'm not changing it. Okay. Yes, this is now finding the information gain. I will do the same thing for all columns, and I will explain you why. For example, if I choose splitting point as income, let's see our data frame again in order to call the columns. Yes, these are my columns. For example, if I choose credit history good as my splitting point instead of income, what will information gain will be? As you can see, information gain is this one when I choose credit history good. And let's do this step low. Yes, when I run, and I will do the same all of the columns, and I will explain you. And I just copy it, as you know, instead of writing from the beginning, and just copy previous code. Yes, as you can see, our algorithm, our function, calculated information gain if I choose this column as a separation point. If I choose, for example, income as a separation point, my information gain will be 1, 2, etc. And if I choose credit history good, my information gain will be 0, 2, and etc. As you can see, I choose all of them as my splitting point. This because I say that this function do this. If I choose splitting point, for example, this one, it's calculate relative or conditional entropy of this splitting point, and it will subtract from the original entropy. And if the result is highest value, it means that it will give me the most information gain. According to these calculations, as you can see here, the income column gives the highest information gain. The next one is this one, collateral no, I think, yes. Collateral no is the second, gives the second highest information gain. Then comes credit history good, and then comes collateral yes, and the least one is the debt low. This means that if I separate the nodes from beginning this debt low column, my data will be much more complicated. It will not be pure. It will be much more dirty. It will be much more mixed with different kinds of data, right? But this income will give me the highest information gain, the highest purity of the separation of the data. When I come back to my this point here, as you can see, we have already printed out the separation of our code. As you can see, this tree export text function will show us the separation points of the entire data. As you can see here, why this one has separated from feature 0. As you can remember, feature 0 represent the income. Yes, we can insert and show you again. These are my data frame. Yes. As you can see, this is my feature 0 because the highest information gain I obtained from feature 0, and that is income. Okay, and after that it goes to other features. Yes, as you can see, the next splitting points are also the next highest information gain. For example, feature 1 is coming the next. It's also very high information gain. Okay, also feature collateral yes is which feature is this? Collateral yes 0, 1, 2, 3, 4, 5. I think it's like yes. I think this code answered the entire questions. And the final, I will also show the visualization of this code. So maybe this also help better to how the code, instead of text, we can also visualize how our algorithm separated our data, right? So we will use, we will create a figure. I will call this one a fig. PLT, I'm using PLT. Matplotlib. Just create a figure, right? Figure. I'm asking creating the fig size. This parameter create figure size. I will say just 20 by 10, and after that, I'm sorry, this one. And after that, I will just connect this one. This tree under library, subset library, as you know, has a plot tree function which shows which will plot the algorithm, how algorithm separated the columns by visualization. Okay, I will just name this here, the name of my algorithm. I name it D3, as you remember, and I will just also write here feature names. What was my feature names? My feature names was df latest. df latest. For example, income. If I feature name income, right? This is the highest separation point. The class name is not this one. Yes. I also another parameter name, class names. This represent my target. This is Y, as you can remember. And I also use another parameter field true. This will create a field version of my visualization. If I run this, field true makes fill these inside this square, each square, okay, fill with the colors. Yes, now I am creating the visualization, a plot tree of the algorithm, right? As you can remember, this is almost the same as this one. This makes a separation point according to the feature one, our income feature, right? If income is fewer than 2,5, it is going this direction. It's again asking again a question. If this income is fewer than 0, going this direction, and ask again a question. If it is fewer than 2,5, going this direction and assigning class. Class means our target as high. This means that this person has highest risk. Okay, this is the visualization of the problem that we have. I think you can use these codes that I write here to any problem you encounter with decision tree. In order to calculate the entropy, the algorithm that scikit-learn has created, use these functions that I have created here. Okay, maybe there are some other features. So algorithms are not so difficult. These people are also programmers like you and I in the future. I hope we will also be good programmers in the future and create our own algorithms. And it is the creation of the algorithm based on this mathematical function I have visualized here. I just use this the mathematical function. This someone else, a scientist or scientists, have find out this is the most useful way to find out the entropy. Entropy means the randomness, the complicatedness of a variable. So I just after that, according to this entropy, you find out the information gain. If any data, any value give the highest information gain, the algorithm choose this highest information gain point as the splitting point of its algorithm, and it's going to the next one, which is the next one, and it creates another splitting point, right? The machine is doing this, but we have the machine because our data is not a data that machine can understand. We just transforming our data in a reasonable way that the machine learning algorithm can understand in numerical values, right? And I will also shortly, our time has passed, but we have also another problem. I just for help you, in order to help you, and at least I want to show you how, because it's all very complicated data, the second data. I want to import this data, and I want to show you how we can transform these all letters into numbers that that the algorithm can understand, right? Yes, mushroom data. I try to remember where I did. I think first of all, I have to find it. Yes, mushroom dataset. I just use this one. I'm just copying the properties and copying the address location of this file, right? Maybe this data name is very long. I can rename it. Just I will call this one mushroom. It's very easy to recall, right? Yes, now it's very clean. Properties, I'm just copying the location of file. You can do the same thing. The name of the file is mushroom. It's a CSV file, as you can see. This is what I downloaded from the professor's file, okay? So I do the same things here. I'm creating, I will use pd.read CSV function because it's a CSV file. Inside quotation marks, I am just passing the address location. I also add the name of the file, mushroom, as far as I remember correctly, and also extension of this file. And I will write here R because otherwise I have to change the direction of this symbol to other side. I'm sorry, pd.read CSV. Yes, this is the data set. This is very long. As you can see, there are 23 columns and 8,123 rows. It's a very long data. I will just call this one df2 data frame 2. This means in order to separate from this one the previous one, df2, right? Yes. Now I call this one. According to assignment, the professor said that we have to choose 21 experiments. This means that randomly choose 25 samples, if I understand correctly. Pandas has this function. We will just call, from entire data set, we will select a sample of 25 data, right? I'm using df2.sample. Sample function or method will give me 25 randomly selected example from entire data set. When I run this one, as you can see, 25 rows and the column names will stay the same, right? I will name this one as sample, right? Because according to assignment, I will not analyze the entire data. I will just analyze the sample. Okay. As you can see, there are a lot of letters, and all of them are df2.info. If I call this one, all of them are strings, right? As you can see, object means in pandas data frames strings. There is no any numerical values. So as I told you before, the machine learning algorithm will understand nothing from the numbers, from the strings. So I have to transform these all letters, complicated letters, into numerical data, right? What I understand from the data, nothing. But the first column represent, I think, edible and poisonous. This is the, I think, the target, as far as I understand from the explanation of the data from the professor's Word document. This first column, P, represent poisonous of this mushrooms, right? If it is A, means it eatable or edible, or poisonous means represented by P, right? This is my target column. The other rest of the columns, which means 22 columns, represent the features, right? So, for example, you can use some also, for example, let's use describe method. This returns us some statistical information about this data. As you can see, number of counts, how many numbers as each column has, the unique values, how many separate value types has. For example, this column P, my target, is only A or P, right? There are two unique values. This means, for example, X, there are 8,000 rows, but it includes only 6 separate value types. This means, okay, with this df describe method, I can easily see how many separate value types each column has included, right? And also this top represents the highestly repeated value type. For example, for my target eatable mushrooms, number of the eatable mushrooms is higher than the poisonous one. For example, when I come to X column, number of X as a type is higher than the rest of the others, right? This is the top value, toply highly repeated in entire column. Okay, it's a good function or method you can use to analyze your data, but you can also, if you, for example, there are 3 dots, this means that this screen cannot include all the name of the columns. Okay, for example, you need to know the column names. With this columns method, you can easily see the name of the columns with entire data set, right? You can, as you can see, it will list it in a list, 23 columns here. All of them are letters also. The values are letters, and also the name of the columns are letters. And you can read the explanation what each letters represents from the explanation or from the Word document. And after importing my data, the next step is to check is there any missing value. Okay. So because I am going from my sample parameter 25, I got randomly 25 rows from the entire data set. I'm just this is null will return you whether is there any missing value or not, right? It will return you Boolean values, false, false, false. As you can see, false. I can check easily here that there is no missing values, but if I add a sum function after that, I can easily see listed in each column here for the left side and how many missing value each has. As you can see, all of them has been listed as 0, which means that there is no any missing value in this data, in my sample, in my first sample. So this is a good news. So this means that I don't need to deal with the missing values, so I can go to the next step. Okay, what next step is? The next step is to deal with the transforming strings into numbers, numerical values, right? Let's do that. Before that, we can separate our data into features and target, right? Feature is easy. Why? I understand that df2.p represents my features, my target. If I run this, as you can see, this is edible, poisonous. This is my target, right? I assign this one to y value, and the rest of the feature will be my features apart from the target one, right? So I will just assign to df2 dot, if I drop just p from my entire data, I will get the feature, the rest of the column, right? I'm going to this mentality. From axis are equal column 1. This means I will drop p column in axis 1, which means columns. I will just drop the p column. This is my feature, and the rest of the data will be my features, right? Automatically. As you can see, there is no p column here, so I can easily. This is the shortest way to assign, instead of just writing each name of the columns, 23 columns. So it's very long work. So I'm just using a simple function, and I assign by drop function. I'm just dropping the target, and the rest will my features, right? So I separated my features and my target. The next step is I will not do nothing with my target, because algorithm can understand strings. There is no problem with the in order to predict the column at the target. But when it comes to features, I have to transform all of them into a numerical value, right? So how I can do all these complicated letters into numbers, right? I previously showed you some methods you can use, but it's a very long and hard job. It will cost a lot of time. But scikit-learn has a very good function that will do this job very easily without using other functions, right? Just I will call this function from scikit-learn preprocessing. This preprocessing includes all the functions inside scikit-learn main library to deal with to prepare the data before machine learning algorithms. So you can be sure that all the necessary functions to deal with the data to prepare the data to the machine learning algorithm is inside this preprocessing sub-library inside scikit-learn main library. I will just import. There are many functions, but as you can see here, these are the list of the functions inside these preprocessing subset library. I will use label encounter because, as you can see, there are just labels, just single letters. So this fits my purpose very good. Label encounter, right? I will call this one label encounter. I will call the function itself, right? I will create after importing these functions. I have to also, this is also valid for the encoding to algorithm. I have to create an instance of this function. And after this instance or the name of the variable, I can use any function inside this function, right? So I will say that, for example, encoder x, because I have separated my columns into two different sections, features as and as target. This will represent encoder x features. You can give any name you want, and because my x features have 22 columns, I will just call a function for column in, for example, this is my x feature columns, right? For example, I can show you what I mean by that. This will list me all the columns inside my features, right? Not this, yes. When I run, and not small x, store x. Yes, as you can see, this will list me. This for loop will go through all the columns inside these columns, and I will, in order to use by each column one by one, I just use it for loop for this purpose. Okay, I'm calling this instance of this function, and I'm using fit transform. This is the method I will use inside this function. Fit transform will transform these labels, these letters, into numbers, right? And I will say x.column name, because I will use this function, this method to enter all the columns inside this x column, from column x, column s, column n. It will go for loop from x. It will use encounter x, this label encoder function. It will use fit transform method and transform all the letters into numbers. And after doing with column x, it will go to the next column, column s, and to the end of the column, until it is ready with all entire columns. Okay, and so I will also x, the result I will assign, because I want to change my the data set, right? Because instead of using the previous x, I will use previous new x column with transformed label encounter function, right? So the result of this function fit transform, I will assign the result the new x column name. So it will assign x column, for example, s. Result will be the new s, right? So when I run this code, for example, Let's call X. As you can see here, now all the X values has been transformed. From the previous methods, I have to deal with one by one. I have to write each column name, but just single a couple of code lines. I just transformed entire letters into numbers that the machine can understand. I will do the same for my Y. I will name this encoder Y, and I will call encoder label encoder function. Yes, I'm creating an instance of this one because this is a single column, so I don't need a for loop. I'm just calling this function. I say that new Y will equal to encoder Y. This is the instance of my label function. I'm just copying and pasting here. And fit transform, I'm using the same method which will transform these letters into numbers. Okay, so fit transform transform Y. So I don't have for loop, so I can easily do this one, and I'm calling Y in order to see. Okay, I misspelled here. Yes. As you can see, all the Y has been transformed into zeros and ones. In my previous, let's call the original data df2 in order to understand what this means. As you can, we are using sample, not entire data set, so I'm calling the sample. Yes, as you can see, Y represents the P column, which means my target, right? So the first item has been labeled as 0 instead of E, or which means that if it is eatable, the computer assigned as 0. So this means negative. It's not positive. But if it is positive, it assigned as 1, right? The next step is yes, and we have to look at what the professor wants us. He wants us random splits of the data into training sets and test set of entire data set as 20%, 80%, 40%. So which means that he wants us to split my sample into training data set and testing data set, right? I'm using the same from scikit-learn dot model selection. I'm using model selection sub library because I will import train test split function, which will enable me to create any number, any percentage of splitting my data as training and test set, right? So when I, for example, help, let's look at what this function is about. As you can see, split arrays or matrices into random train and test subsets, right? When you go through the documentation, you will generally documentation gives you a good example of how you can use this one, right? I'm just copying this one because basically this function will do is split my X data set as X train and X test, and also do the same thing for my Y data set, right? Inside the function, I am just assigning my X, not this one, my X. First, it will come to X, my features, and it will split train and test data set, and it will come to the Y and do the same thing for the Y target data set. And how it will do that, I will arrange how many my training data set or testing data set will be. by using this test size parameter. This means, for example, this is the default one. It will use 33% of the data as test set, which means 67% will be assigned as training data set, right? But according to the assignment, you will use, for example, let's choose this one. You can repeat the same process after me. Let's choose this one, 20% as my test data set and 8% as my training data set, right? Generally, we use a testing data set as far as favor than the training data set, because in order to get a better machine learning prediction, I have to train the algorithm as far as possible, but I have to away from the overfitting, and we will come to this one. If I write here 0,2, which means that please use 20% of the entire data as my test, and it will automatically will assign 80% as a training data set, right? And this answer the next step, okay? When I run this code, if I didn't make any mistake, let's do this. I will not use random state because my random state means I am assigning the splitting point 43, but my data is not so long, right? So let's look at this. One error. Did I wrong anything? My sample. Let's check this one. Y dot size dot shape. Yes, this is the shape of my target. X dot shape. Oh my God. We made a mistake when we assigned to, because we use our sample as our target, but we use features entire data set. But according to assignment, we will not use entire data set. So we have to correct X. So I'm coming to the, as you can see, I made mistake. So instead of, I have to use sample P, because I'm selecting 25 examples from sample, not entire data set, because DF2 represent entire data set, right? I have to run these columns again. Yes. Now, yes, my X is okay, my Y is okay, I think. Yes, 25 rows, and also this is 25 rows. Yes, now we can go, we have to run the same code again. It happens. Yes, not entire data set. Just I'm correcting and rerun, because I have to rerun. When I run this one, no, there is no problem here, right? We corrected because we made a mistake. We assigned our sample target data into our Y, but when it comes to X features, we assigned entire data set, and it's a mistake because it is not matching. In training test splitting, the size of each data set should match with each other. For example, let's look at X training set. This is X training set. This is the data features that the algorithm we will use to train our algorithm. This is the data set, X data features, that we will use to test our algorithm's performance, right? It has selected 5 rows because I just used 20%, which means 1 divided by 5, which means 25, it means 5 examples, right? In a simple mathematics. Let's look at our Y. Y train. As you can see, this is the training of the algorithm, the data I will use to train of the algorithm. The algorithm will use these features in X training set to create a function or hypothesis to predict the best hypothesis to predict the Y training set. So, and let's look at the test, Y test. As you can see, it is also have 5 examples, right? The true label should be this one, but the algorithm does not know beforehand, right? So let's look at the performance of the algorithm, and so we have to now our data has been split as training and test set according to assignment. Let's look at the performance of our algorithm, right? From scikit-learn, I use the same thing. I will call the same algorithm because we are using decision tree. From tree sublibrary, I will import decision tree classifier because it's also a classification problem, right? Because I will predict whether a mushroom is eatable or poisonous, not a numerical value, not a continuous value. If I, for example, predict a 1,000 prices in Kristiansand, it changes. There we can find a lot of different prices, right? So there is no group, there is no category. But when it comes to this data, there is only 2 categories, and this is a classification problem. And so I have to use the right algorithm, classifier algorithm of the decision tree. And let's the next step after calling the algorithm, the D3 is I will assign this one an instance of this algorithm, right? I have to say D2 because D3 first I have used the first data set, so I have to use a new name, I think. D2, I will just name this one. You can say model or something like that, function, whatever you like, but mainly I use this name. And after that, I will just fit my instance of the algorithm to my X train data set and Y train data set, right? Because now I am that fit, I have to use fit function. Now I am fitting the algorithm training set, right? I say that create your splitting points in your decision tree algorithm. This is my features. This is my target. Create best splitting points, best nodes according to the information gain. The algorithm creates the best splitting points, and when I use the tests data set, it will use these splitting points and implement the same splitting points to my test data, right? And it will create why the target data should be according to test data. Now, as you can see, when I run this means that algorithm has fitted the data, has created its own hypothesis, and now I'm creating my predictions. Decision tree D3 2.predict. I use the same thing, as you can see. I will just assign this just my X test because I don't want my algorithm knows my Y test, okay? But there is no problem. It should know the X test because these are features. It will predict according to these features. So I have to write here the features, right? Not train, not Y's, but only X test. You should be attention about this, careful about this. As you can see, the algorithm has predicted this Y, and this is my original data. As you can see here, Y says that algorithm doesn't know. As you can see, according to this X test, let's look at the X test. When I feed by this X test, if the mushroom has these features, my algorithm predicts the first one, this one is the first one, as not poisonous, eatable. This means 0 means eatable. And the second one, poisonous. The third one is eatable, and the other ones also eatable. The original data, I'm sorry, this is the original data. My algorithm predicts all of them are eatable. And if you trust this algorithm, if you eat the second mushroom, you will have to go to the hospital. It means so, but the performance is not bad because we are use very good, very few sample size, right? 25 is not good enough, I think, to create a better performance. I think we have to use much more sample size, but we have to follow the assignment. Yes. Now let's look at the performance measurement, right? How I can see how it performs, but for the assignment, I have to show that with Python codes how the performance of this algorithm to predict the y-test, whether a mushroom is eatable or poisonous. Let's look. I use for classification problem from scikit-learn, right? That matrix gives the all performance measurement tools in entire scikit-learn, right? Import. For classification problems, I use classification report. This will report precision, also truthness of the algorithm predictions, and also confusion matrix. This is very important. I think you have to use in your future works also. And I will just print the results of these performance measurement tools, right? Yes, the first thing I will write here the test, the original test, because now I compare. This is the original test y values. This is my predictions of the algorithm, right? For predictions, I have to create my predictions or predictions variable name because I want to use this one here when I use this the performance method. Yes, predictions. Yes, let's do this. As you can see, this is the performance of the algorithm. This means that the precisions of the algorithm is 80%. If it is eatable, the performance is 80%. But if it is poisonous, performance is 0. As you can see, the original test, our algorithm predicted. Where is our algorithm? Yes, let's look at the predictions. Predictions. Yes, our algorithm predicted all of them as 0, but the second one should be 1. So therefore, it says that when it comes to predicting the poisonous one, our algorithm scored 0. It cannot predict any of them, but it's not a big problem because we have only one sample of the 5 examples. This is the recall of the our algorithm. It means that our algorithm, when it comes to prediction of the eatable ones, 100% it can predict, but when it comes to poisonous one, it is 0. Okay, this a little bit absurd result is because of the size of our sample. If we had used, you can also use the entire data set, the same codes. Just you have to assign not sample to but entire data set. You can get maybe the better results. But let's follow the assignment. It also demands us report the average performance as well as 90% confidence interval, right? So we have to also, these are the results. Let's also use the confusion matrix, the results of the confusion matrix. Instead of, I will use the same things, but not classification report function. Confusion matrix. This is the original data, the real data, actual data. These are my predictions. I assign these values. Yes, as you can see, this is true positive. This means that it has 4 of them. It predicted good. Okay, but this is false negative. It predicted false, 1 of them. We don't have time, so I will just use how we can create confidence interval by using Python code. Okay, from stats model, this is another library. Stat models dot stats. This is sub library dot proportion. Import proportion report. Proportion conflict. This is hard, difficult to memorize all of this. So I'm just I don't memorize these ones because you cannot memorize all of these codes. You have to look from internet and something else. But what you have to learn, how can you find the exact codes? Yes, if I didn't misspell conflict, right? If I don't, yes, that's good. Let's create a function. I will use inside this function. I create my own function, but inside my own function, I will use this function, right? Let's name this one confidence. Confidence interval, right? Lower value and upper value. I will assign my parameters, and lower, upper are equal to, and now I am using the function, right? This function will do, inside the function I assign, let's remember what our prediction is right. Let's look at why real data is. So because we have to use inside this function these values, tests. Yes. As you can see, in 5 examples, I will assign how many right answer my algorithm has predicted, right? In 5 examples, there are 5 examples, right? 5 predictions, but just one of them is missing. Yeah, it's failed. So it has predicted 4 of them right in entire 5 samples, right? So after that, because professor said, ask about us 90% confidence level, this means that 0.5. This means this will use 90. This means 90% in a opposition mentality. It will, with this 90% confidence level, it will find out the lower point of our confidence to predict the data is correct or not, and the higher upper point, right? And I will just return the result of this function, right? Let's use a statement here. Let's write it. Lower is equal. We have learned from Python, right? Inside here, I will name my parameter name. Lower is equal, and comma, my upper, right? My upper value is equal to, inside this, I will name upper one. Yes, when I run this, if I didn't make any mistake, let's call our function confidence level, right? Confidence level, I made a mistake. Confidence interval. I'm sorry. This one, yes. Let's run this one again. I'm just calling my own function. My upper point is 4, right? And my mistakes is 5. So let's print this one, the result of my function. Yes, when I print this, as you can see, we have predicted 4 of them of 5 examples right, our algorithm predicts right. But if we implement 90% confidence level, it means that you can trust the predictions of algorithm at least 20%, 50%. This is the percentage of the lowest trustness of your algorithm or confidence levels of your algorithm. This is the highest level.